In this video, we're going to go over gas mixtures and partial pressures. A gas mixture is a mixture of gases that contain two or more gases. This is the composition of air. We have nitrogen, which makes up about 78% of air. Oxygen makes up about 21% of air. Argon and carbon dioxide make up a small part of air. There's also some water vapor in air. Partial pressures. Dalton's law of partial pressure. For a mixture of gases, each gas exerts a pressure independent of other gases, behaving as if it alone occupied the total volume. And partial pressure, or P sub n, is the pressure of a gas in a mixture. So the total pressure of a gas mixture is equal to the sum of the partial pressures of each gas in the mixture. So if you had 3 gases in a mixture, the total pressure of the mixture would be equal to the partial pressures of each of those 3 gases. So oxygen makes up about 20.95% of the atmosphere. At sea level, which is 760 millimeters mercury, the partial pressure of oxygen is 20.95% of the total pressure, which is 159 millimeters mercury. On Mount Everest, the atmospheric pressure is 400 millimeters mercury. The composition of air is about the same. And so the partial pressure of oxygen on Mount Everest is still 20.95% times the 400 millimeters mercury, so the total pressure. And so 84 millimeters of mercury is the partial pressure of oxygen on Mount Everest. A mixture of only nitrogen and oxygen has a total pressure of 3 atmospheres. If the partial pressure of oxygen is 0.63 atmospheres, what's the partial pressure of nitrogen inside a tank? So we know, due to Dalton's law of partial pressures, the total pressure of a mixture and the total pressure inside this tank is going to equal the partial pressure of nitrogen plus the partial pressure of oxygen. And only oxygen and nitrogen are present, so that's the only things that make up this mixture. The total pressure is 3.00 atmospheres. We want to know the partial pressure of nitrogen, and we know the partial pressure of oxygen is 0.63. So we're going to subtract 0.63 from each side, and we get the partial pressure of nitrogen is 2.37 atmospheres. Henry's law. Henry's law is the partial pressures are also used to determine the amount of gas that dissolves in a liquid. Blood serum contains dissolved gases such as oxygen, nitrogen, and carbon dioxide. Henry's law states that the number of moles of gas, or N, dissolved in a liquid is directly proportional to the partial pressure of the gas. So the greater the partial pressure of the gas, the greater the number of gas molecules dissolved in liquids. The more gas molecules there are, the higher the partial pressure of the gas is going to be. This is the equation for Henry's law. The temperature is constant. P is the partial pressure of the gas, so it's not the total pressure, it's the partial pressure of the gas. KH is Henry's constant. This is unique for each gas. And C is the concentration of the dissolved gas in moles per liter, so the molarity of the dissolved gas. The concentration of the gas increases as the partial pressure increases. Anesthetics have different Henry constants, or KH values, because every gas has a different KH value. KH values determine how quickly the anesthetic reaches the brain. It also determines the time needed to regain consciousness. So Henry's law is pressure is equal to Henry's constant time concentration. This can be arranged to concentration is equal to the pressure over Henry's constant. So if you have a smaller Henry's constant, the concentration is going to be greater. So diethyl ether has a relatively small Henry's constant, and therefore the concentration of diethyl ether dissolved in the blood is going to be greater. So this is, remember, this is the concentration in the blood, smaller Henry's constant, greater concentration in the blood. Because more diethyl ether molecules are dissolved in the blood, they don't reach the brain as quickly as an anesthetic with a larger Henry's constant. Patients anesthetized with diethyl ether take longer both to become anesthetized and to regain consciousness. Diethyl ether was one of the first anesthetics. It is no longer widely used, and it's because of that reason. A gas mixture contains two or more gases. Dalton's law states that the total pressure of a mixture of gases is equal to the sum of the partial pressures of each of the gases. Henry's law shows that the moles of gas dissolved in solution are proportional to the partial pressure of the gas.